This is Chapter 9, Section 5 in your textbook, Adding and Subtracting Rational Expressions. So let's say you are given a problem like this. 1 over x squared plus 5x plus 4 plus 5 over 3x plus 3. Now what you have to do is you have to make the denominators the same. And you do this the same way you would for a normal fraction. You find the factors of the denominators. So in this case, that would be 1 over x plus 1 times x plus 4, which is this equation here factored out. And then we just factor the 3 out here, so it's 3 times x plus 1. Now notice that they do have a factor in common, x plus 1. So what you're going to do to make the denominators the same is multiply each fraction by the factor that they do not have in common. So that's going to look like this. So for this first one, we're going to multiply it by 3 because this fraction does not have the 3 as one of the factors. So when we multiply that out, that becomes 3 over 3 x plus 1 x plus 4. Okay, then we do the same thing for the second fraction, except this time we're going to be using x plus 4 because that is the factor that it does not have in its denominator. So when we multiply this out, this becomes 5x x plus 4 over 3 x plus 1 x plus 4. Okay. Now if you notice, the denominators are now the same. We have 3x plus 1, x plus 4, and 3x plus 1, x plus 4. So we can combine them the same way we combine normal fractions. We just add the numerators. So this equals 3 plus 5x times x plus 4 over 3x plus 1 x plus 4. Okay, and all we have to do now is just simplify it. So this is our final answer. And what we're going to do is just simplify the numerator. So this becomes 3 plus 5x squared plus 20x. And then you can put that in order if you want to. And then we leave the denominator the same. Okay, and that would be your final answer, and you would put those in order. Now also in this section are complex fractions. And what a complex fraction is a fraction inside of a fraction, so something like this. And there are two ways in your book to solve a complex fraction. I'm going to teach you the second way because it just makes more sense in the long run. So let's say you have this particular complex fraction. So you're going to treat the numerator and denominator as two separate problems. So let's just look at the numerator first, okay? So the numerator is 1x plus 3, and what we're going to do is we're going to make this 3 have the same denominator as this. So in that case, that would be x. So we multiply 3 by 1, which is the same as x over x, and so that becomes 1 over x plus 3x over x, and now they have the same denominator, and what we can do with that is we can combine the top. So 1 plus 3x over x. Okay, now we're going to leave that for a moment, and we're going to go to the denominator. And we're going to do the same thing, but instead of using x, this time we're going to multiply 4 by y over y, which is the same as 1. So this becomes 5 over y plus 4y over y. And once again, we now have the same denominator, so we can combine them. And this becomes 5 plus 4y over y. Okay, now your final answer Okay, so right now this is the fraction we have now created. So we have 1 plus 3x over x over 5 plus 4y over y. And this looks even more complicated than the original thing, but if we think of this as a division problem, it becomes very simple. So if we think of it as 1 plus 3x over x divided by 5 plus 4y over y, all we have to do is multiply by the reciprocal. So if we have 1 plus 3x over x times the reciprocal of this denominator here, so y over 5 plus 4y, then this becomes very easy to solve. And all we have to do is just multiply the top and bottom. So this becomes y plus 3xy over 5x plus 4xy. And that's your final answer.